Let's do a quick introduction to Mimo channel estimation. This is multiple input, multiple output. So we have multiple transmit antennas and multiple receivers in a digital communication system. We can write that as an equation where the output vector y, which is a vector of all these elements of measurements, equals the matrix H times the vector x of inputs plus noise. And in order to estimate the transmitted data, you need to know the channel matrix H at the receiver. So how do we estimate that? Well, the common way is to send training data, where you send data that is known to the receiver. And so the receiver measures Y, it knows what X is, it knows what was sent in the training data, and then it can use that to estimate H under the uncertainty from the noise. Now, to do that in Mimo, you can quickly see that if you send training data from all of the antennas at the same time, then they will all be interfering with each other at the receiver. So what we do instead is we send off each antenna separately, one after another. And that leads us to look at the H matrix column by column. So here we've got the first column, the second column, the third and fourth in this 4x4 example. And so when we're sending data off the first antenna and not sending anything off the others, then we are looking at the first column of the H matrix. And for the X matrix has this form here, where we're sending symbols off the first antenna and nothing off the others. So let's look at that. We'll look at the first column, and all of the other columns are, of course, similar. Now, the key to estimating the columns of H is to rewrite this matrix in a form where we can use estimation techniques such as least squares to estimate the columns one by one. When we're estimating the first column, we use X like this. We send off the first element. When we're estimating the second column, we would use a vector with an X in the second element, zeros elsewhere, and that would be for transmitting off the second antenna, and so on. So the key is rewriting this equation. So let's look at how we rewrite it. So here's the way this Y value in this particular case of the one shown here, we can form this matrix here from this vector, and it has the same result as this equation in this special case. And you can confirm that for yourself. Now, what we're doing is we're sending a single symbol, but if we want a good estimate of H, we will need to have multiple measurements. And for information on how to do least squares estimation, check out the description below. There's a video on the least squares estimator. But what we can see is if we have multiple of these, we send one symbol at one time and then another one and so on, then I can put a subscript on here. This is all X1, and this would be giving us a measurement Y1, and there will be noise vector N1. If we send a second subsequent symbol off the first antenna, then we can simply extend this matrix here in this way here, where we've got the second element like this. And this is still a matrix which has 4 columns. So you're still multiplying by the same channel vector here. And what we then have is an extension of this noise vector here, which will have a second element to the noise vector. And there will, of course, be a second measurement that you are measuring in your measurement vector, and so on. And this can be extended as many symbols as you want to send. And the more symbols you send, the better your estimate of the channel column vector. Now, if we call this vector here, I'm going to call this Y tilde with a bar over the top, then we can write down the least squares estimate for the channel vector, the first vector of the matrix H. And if this is we call this capital X, then this is the standard least squares equation, and we'll get an estimate of the first column of H. Now, as we said, then you can transmit off the second element by shifting this X down, and then rewrite in the same way to then get an estimate for the second column, and so on. So hopefully this has given you more insight into channel estimation for Mimo. If it has, give the video a thumbs up, helps others to find the video. Check out the description below, where you'll find a web page with a full categorized listing of all the videos on the channel, And of course, subscribe to the channel for more videos.